Tonight I want to take you somewhere special, somewhere that exists all around you at this very moment, yet remains completely invisible to your eyes. It's a place where the very fabric of reality is gently, constantly bending and warping, where light itself curves in ways that would seem impossible if you didn't know the quiet truth of it all. You see, right now, as you're settling in wherever you are, whether you're tucked into bed or resting on a couch, whether it's late at night or perhaps you're stealing a moment of peace during the day, light is bending around you. Not metaphorically, not poetically, but literally, physically bending as it passes through the space near your body. And the most remarkable thing is that you can't see it happening. I wonder where you are right now as you listen to these words. Are you in a bustling city where millions of people are creating their own tiny distortions in space-time? Or perhaps you're in a quiet countryside where the stars above are sending their ancient light through the curved space around our planet? What time is it where you are? Is it that perfect drowsy hour when the world feels soft and distant? Or are you creating your own pocket of tranquility in the middle of a busy day? Wherever and whenever you are, I'm grateful you've chosen to spend this time exploring one of the universe's most gentle secrets with me. If you find yourself drawn into this cosmic mystery, if you feel that quiet pull of wonder, perhaps you'd like to subscribe for more of these sleepy journeys through the cosmos. Consider it an invitation to return whenever you need to drift away into the peaceful depths of scientific wonder. It's a question that might sound strange at first, something you could easily dismiss as either too technical or too subtle to matter. Why would light bend around you? And even if it does, why can't you see it? But the more we look at it, the more quietly intriguing it becomes. What if this invisible bending of light was not just a dry equation in a physics textbook, but a quiet doorway into understanding that you, yes, you, are literally shaping the universe around you simply by existing? What if every atom of your being is gently pulling on the cosmic fabric, creating tiny ripples that affect the path of every photon that passes near you? We're about to embark on a journey that will take us from the familiar comfort of your immediate surroundings to the vast expanses of space, from the simple act of light traveling across your room to the profound ways that mass and energy shape reality itself. We'll discover together why Einstein spent sleepless nights pondering this very phenomenon, why astronomers use this principle to see galaxies that should be hidden from view, and why, despite all of this bending happening constantly around us, our eyes remain beautifully oblivious to it all. You and I were going to explore this together, gently, without any rush. We'll let the ideas unfold like starlight spreading across a dark sky, taking our time to understand not just what happens, but why it matters that you, in your seemingly small and quiet existence, are powerful enough to bend light itself. And perhaps most wonderfully, we'll discover why the universe has arranged things so that this constant warping remains hidden from our everyday perception, allowing us to move through our lives without being overwhelmed by the cosmic dance happening at every moment. Let's begin by imagining light itself, not as we usually think of it, switching on a lamp or watching the sunrise, but as countless tiny messengers, photons, racing through space at the ultimate speed limit of the universe. These photons have been traveling for different amounts of time. Some left the sun about 8 minutes ago, bouncing off clouds, windows and walls before reaching your eyes. Others have been journeying for years from distant stars, and some, the truly ancient ones, have been crossing the void for billions of years, carrying messages from galaxies so far away that they appear to us as they were when the universe was young. Now, here's where it gets quietly fascinating. Every single one of these photons, whether they've traveled for nanoseconds or eons, must obey a fundamental rule of our universe. They must follow the curves of space-time. And space-time, this invisible fabric that holds everything, isn't flat like we might imagine. It's warped, curved, dimpled, and stretched by every bit of mass and energy it contains. The Earth beneath you creates a significant dent in this fabric. The sun creates a much larger one. Even the moon tugs at space-time in its own gentle way. But here's the part that might surprise you. You do too. Yes, you. With your collection of atoms arranged in the pattern that makes you who you are, you're bending space-time right now. It's not much, granted. You're not creating the kind of dramatic warping that a star or planet does, but it's there, real and measurable in principle, if not in practice. Every atom in your body has mass, and mass tells space-time how to curve. This isn't poetry or metaphor. This is the fundamental architecture of reality as described by Einstein's general relativity, tested countless times and never found wanting. The reason you can't see this bending is beautifully simple and profound at the same time. The curvature you create is so gentle, so subtle, that light barely notices it. A photon passing right by your skin might deviate from a perfectly straight path by an amount so small that we don't have instruments sensitive enough to measure it directly. We're talking about deflections smaller than the width of an atom, changes in trajectory so minute that they make no practical difference to how light behaves in your everyday experience. But let's think about this more deeply, more contemplatively. What does it mean for light to follow a curved path? In our everyday understanding, light travels in straight lines. We see this when sunbeams pierce through clouds or when we use a laser pointer. But these straight lines are actually an illusion, or rather, they're straight only in the local sense. The photons are following the straightest possible path through curved space-time, what physicists call a geodesic. It's like an ant walking in what it thinks is a straight line on the surface of a basketball. From the ant's perspective, it's going straight, but from our three-dimensional view, we can see it's following the curve of the ball. You're like a tiny basketball in the fabric of space-time, creating your own small curvature that light must navigate around. But unlike a basketball, which we can see and touch, your gravitational influence on light is invisible, imperceptible, yet absolutely real. It's happening right now, as billions of photons stream past you, each one taking a path that's ever so slightly different than it would if you weren't there. Let me take you now to places where this bending becomes more dramatic, more visible, so we can better understand what's happening around you on that tiny, invisible scale. Imagine we're floating in space, far from Earth, watching as starlight passes by our sun. During a total solar eclipse, when the moon blocks the sun's blinding disk, astronomers can see stars that should be hidden behind the sun. How is this possible? The sun's massive presence warps space-time so significantly that light from these stars curves around it, bending just enough to reach our telescopes. This was one of the first confirmations of Einstein's theory, observed in 1919, and it changed our understanding of the universe forever. The sun, with its mass of 2 octillion kilograms, bends light by about 1.75 arc seconds when the light passes right at its edge. That's a tiny angle, about the width of a human hair seen from 20 feet away, but it's enough for our instruments to detect. Now let's scale this down to you. Your mass might be, say, 70 kilograms. The bending you cause is proportionally smaller, so small that we need to venture into the realm of numbers with many zeros after the decimal point. We're talking about deflections measured in fractions of fractions of fractions of arc seconds. But here's where it becomes even more interesting. It's not just your total mass that matters, but how that mass is distributed. You're not a point particle or a perfect sphere. You're a complex arrangement of atoms, mostly empty space actually, with dense bones, flowing blood, electrical signals zipping through neurons, and the constant dance of chemical reactions. Each part of you contributes to the overall warping of space-time in its own way. Your beating heart, with its rhythmic compression and expansion, creates tiny ripples in the gravitational field. Your breathing, the rise and fall of your chest, sends almost imperceptible waves through the fabric of space around you. Scientists have calculated that if you could somehow measure the gravitational field around a human body with sufficient precision, you could detect their heartbeat from the tiny variations it causes. Think about that for a moment. Your heartbeat doesn't just pump blood through your veins, it sends gravitational waves through the universe. These waves are incomprehensibly weak, so weak that they've never been directly detected, but they exist. They propagate outward at the speed of light, carrying information about your existence into the cosmos. We live in an age where we can detect gravitational waves from colliding black holes billions of light years away. The LIGO and Virgo detectors can sense distortions in space-time smaller than 1,000th the width of a proton. Yet even these miraculous instruments couldn't detect the gravitational influence of a human being. We would need technology millions or billions of times more sensitive. But the principle remains. You are a source of gravitational waves, a tiny broadcaster sending signals into the universe with every movement you make. Let's return to the light bending around you and think about it from a different angle. Every photon that enters your eye has had its path influenced by your gravitational field. It's a tiny influence, yes, but it's there. The light from your computer screen or phone, the light from the stars, the cosmic microwave background radiation that's been traveling since the universe was young, all of it curves ever so slightly as it approaches you. In a sense, you're seeing the universe through the lens of your own gravity. This might seem like a trivial detail, something so small it couldn't possibly matter, but it speaks to something profound about the nature of reality. There is no such thing as truly empty space, no place where space-time is perfectly flat. Every particle of matter, every quantum of energy, contributes to the cosmic geometry. You can't exist without affecting the universe around you. Your very presence changes the paths of particles and waves, creates ripples in fields, alters the quantum vacuum state in your vicinity. We often think of ourselves as separate from the cosmos, as observers looking out at the universe. But the reality is much more intimate. We're not just in the universe, we're part of its fabric. The same laws that govern the motion of galaxies govern the light bending around your body. The same equations that describe black holes describe the tiny warping you create. There's a beautiful unity in this, a connection between the cosmic and the personal that runs deeper than we usually imagine. Consider for a moment the photons that are passing through your room right now. Some of them have come from your lamp or overhead light, created just moments ago by excited electrons dropping to lower energy states. Others have filtered through your window from the sun, born in nuclear fusion reactions in its core hundreds of thousands of years ago, but only recently escaping to make the 8-minute journey to Earth. Still others, invisible to your eyes but detectable with the right instruments, are radio waves from distant galaxies, infrared radiation from warm objects, microwaves from your Wi-Fi router, and the faint afterglow of the Big Bang itself. All of these photons, regardless of their origin or wavelength, must respect the curvature of space-time around you. They all bend ever so slightly as they pass by. It's happening continuously, a constant dialogue between light and gravity, between energy and geometry. And you're not just a passive participant in this cosmic dance. Your gravity, weak as it is, contributes to the choreography. Let's delve deeper into why you can't see this bending. Our eyes evolved to detect patterns and changes that matter for survival. We can see objects, colours, movement and shadows because these things helped our ancestors navigate the world, find food and avoid danger. But the bending of light due to gravity at human scales is so far below the threshold of biological relevance that there was never any evolutionary pressure to develop the ability to perceive it. Our eyes can detect single photons under the right conditions, a remarkable feat of biological engineering. But detecting the gravitational bending of light would require something else entirely. We would need to be able to measure the precise trajectory of photons, compare them to what they would be without gravitational influence, and do this for enough photons to build up a picture of the gravitational field. It would be like trying to map ocean currents by watching individual water molecules. Even if we could enhance our vision with technology, seeing gravitational light bending at human scales would be extraordinarily difficult. The effect is so small that thermal vibrations, air currents, and even the quantum uncertainty in photon paths would overwhelm it. It's hidden not just by its subtlety, but by the noise of countless other phenomena that operate at similar or larger scales. But perhaps this hiddenness is a gift. Imagine if we could see every gravitational distortion around us. Every person would appear surrounded by a faint warping of space. Every object would distort the light passing near it, and the simple act of looking at the world would become overwhelming in its complexity. The universe has arranged things so that we can function without being constantly aware of the deep physics underlying our every experience. There's another layer to this mystery that we should explore. The bending of light we've been discussing is just one manifestation of a deeper principle, the equivalence of gravity and acceleration. Einstein realized that being in a gravitational field is indistinguishable from being in an accelerating reference frame. This means that the light bending around you is related to the same physics that causes light to bend in an accelerating rocket ship or a spinning space station. From the perspective of general relativity, you could say that you're not really bending light at all. Instead, you're curving space-time, and light is simply following the straightest possible path through that curved geometry. The bending is only apparent when we try to impose our flat space intuitions on a curved reality. This shift in perspective, from forces acting on objects to objects following geodesics in curved space-time, was one of Einstein's greatest insights. Think about what this means for a moment. The space around you isn't just empty volume waiting to be filled, It's a dynamic, responsive medium that carries information about the distribution of matter and energy. Your presence literally changes the properties of space and time in your vicinity. Clocks run slightly slower in your gravitational field than they would in empty space. Distances are slightly different. The very meaning of straight is altered by your existence. We can measure these effects for Earth, and they're significant enough to matter for GPS satellites, which have to account for both special and general relativistic effects to maintain their accuracy. The satellites experience time differently than we do on the surface, running faster by about 45 microseconds per day due to gravitational time dilation. Your body creates similar but much smaller time dilation effects. A clock at your feet runs slightly slower than one at your head, though the difference is so small it would take billions of years to accumulate to even a second. Yet this isn't just about clocks and satellites. It's about the fundamental nature of existence. You exist in a universe where space and time are flexible, where matter and energy can reshape the stage on which all events occur. And you're not just performing on this stage, you're helping to shape it. Every atom in your body contributes to the local geometry of space-time. Every movement you make sends ripples through the gravitational field, and every photon that passes near you must acknowledge your presence by adjusting its path. Let's take a journey now into the microscopic realm, where things become even stranger. At the quantum level, particles don't have definite trajectories. They exist in superpositions of states, taking all possible paths simultaneously until observed. This includes photons passing near you. In the quantum description, each photon explores all possible routes, including those that bend around you to varying degrees. The path we observe is just the most probable one, emerging from the interference of all these quantum possibilities. This quantum view adds another layer to our mystery. Not only is light bending around you in ways you can't see, but it's also exploring paths that bend even more dramatically, paths that loop around you multiple times, paths that seem to violate our classical intuitions. These exotic trajectories contribute tiny amounts to the overall probability amplitude, but they're there, part of the quantum foam that underlies reality. Some physicists speculate that at the smallest scales, smaller than we can currently probe, space-time itself might be quantum, fluctuating and uncertain like everything else in the quantum realm. If this is true, then the gravitational field around you isn't smooth and continuous, but fuzzy and probabilistic at the tinier scales. Light passing through this quantum gravitational field would experience not just the average bending we've been discussing, but also random fluctuations, a kind of gravitational noise that might, in principle, be detectable with sufficiently advanced technology. We're venturing now into the realm of quantum gravity, one of the great unsolved problems in physics. We don't yet have a complete theory that unifies quantum mechanics and general relativity, but we know such a theory must exist. And when we find it, it will likely reveal even more surprises about how light and gravity interact at the smaller scales, perhaps even at the scales relevant to human bodies. But let's return to the classical picture for now and consider some of the more measurable effects of your gravitational field. Scientists have proposed experiments to detect the gravity of small masses in laboratory settings. One approach uses incredibly sensitive instruments called atom interferometers, which can measure tiny changes in the paths of atoms due to gravitational fields. Another uses torsion balances, modern versions of the device Cavendish used to first measure the gravitational constant over 200 years ago. These experiments are pushing the boundaries of what we can measure, trying to detect the gravity of masses as small as a few milligrams. That's still much larger than individual atoms, but it's getting into the realm where quantum effects might start to matter. If we could measure the gravitational field of something as small as a virus or a large protein molecule, we might start to see the intersection of quantum mechanics and gravity in a new way. Your body, of course, is much more massive than what these experiments typically study. But the principle is the same. You're a gravitational source, bending light and warping space-time, just operating at a scale that falls into a kind of measurement gap. Too large for quantum gravity effects to be significant, too small for classical measurements to easily detect. There's something poetic about existing in this middle ground. You're large enough that your gravity is definitely classical, following Einstein's equations to extraordinary precision. Yet you're small enough that your gravitational effects remain hidden from everyday perception, allowing you to move through the world without constantly being reminded of your role in shaping space-time. Let me share with you some numbers that might help put this in perspective. The gravitational field at the surface of Earth is about 9.8 meters per second squared. The gravitational field at the surface of your body, if we treat you as a sphere for simplicity, is about 0.01 meters per second squared. That's 100 millionth of Earth's gravity. The deflection angle for light grazing your body would be about 0.001 arc seconds. That's so small that light from a star would have to pass within millimeters of your skin to be deflected by even one atom's width, over a distance of a light year. These numbers might make the effect seem negligible, and in practical terms it is. But the fact that we can calculate these numbers, that we can apply the same equations that describe black holes and galaxies to human bodies, reveals the beautiful universality of physical law. There's no special cutoff where gravity stops working, no minimum mass required to bend space-time. Every bit of matter participates in the gravitational interaction, from the smallest dust grain to the largest galaxy cluster. And here's something even more wonderful to contemplate. The gravitational field around you extends infinitely in all directions, getting weaker with distance but never quite reaching zero. In principle, your gravitational influence reaches every corner of the observable universe. Of course, at cosmic distances your gravity is so weak that it's utterly negligible compared to local effects. But it's there, encoded in the fabric of space-time, a tiny contribution to the overall geometry of the universe. This means that you're gravitationally connected to everything. The moon feels your pull, though it's far too small to measure. The sun, the stars, distant galaxies, they all respond to your gravity in principle, even if the effect is smaller than the smallest thing we can imagine. And likewise, you feel their pull. The gravity of distant galaxies, weak as it is by the time it reaches you, still contributes to the local space-time curvature you experience. We live in a gravitationally connected cosmos, where every mass influences every other mass, where the geometry of space-time at any point depends on the distribution of matter and energy throughout the universe. This is encoded in Einstein's field equations, which relate the curvature of space-time to its energy and matter content. These equations are nonlinear, meaning that gravitational fields can interact with themselves, creating complexities that we're still working to understand fully. Your gravitational field interacts with Earth's, creating a combined geometry that's slightly different from what either would create alone. This combined field interacts with the moons, the suns, and so on, creating the complex gravitational environment we actually experience. When we send spacecraft to other planets, we have to account for these interactions precisely, calculating how the gravity of multiple bodies will affect the trajectory. But for light passing near you, Earth's gravity dominates so completely that your contribution is like a tiny ripple on an ocean wave. The photons are primarily responding to Earth's warping of space-time, with your body adding just the faintest additional curvature. It's there, it matters in the absolute sense, but it's hidden in the shadow of much larger effects. Let's consider now what would happen if we could somehow amplify your gravitational field, make it strong enough to visibly bend light. This is pure thought experiment, of course, but it helps us understand the physics involved. If your mass were compressed into a much smaller volume, the gravitational field at your surface would be much stronger. Compress yourself down to the size of a marble, and a light passing close by would bend noticeably. Compress further, down to millimeters, and you'd start to see dramatic lensing effects, with light bending in ways that would distort the appearance of objects behind you. Continue this compression to its ultimate limit, and you'd reach your Schwarzschild radius, the point at which you'd become a black hole. For a human mass black hole, this radius would be incredibly tiny, about 10 to 25 meters, far smaller than any elementary particle. At this point, your gravity would be so strong that not even light could escape from your surface. You'd have gone from imperceptibly bending light to trapping it entirely. Of course, this is impossible with known physics. There's no way to compress ordinary matter to such densities. But the universe does it naturally in the collapse of massive stars, creating black holes that can bend and trap light in the dramatic ways we observe with our telescopes. These cosmic light benders follow the same equations that describe the tiny bending around your body, just taken to extremes that nature achieves only in its most violent events. Understanding the light bending around you also helps us appreciate one of the universe's most useful phenomena, gravitational lensing. Throughout the cosmos, massive objects act as lenses, bending light from more distant sources. Galaxy clusters can create multiple images of the same distant galaxy, or stretch them into long arcs. Even individual stars can lens the light of more distant stars, briefly brightening them in events called microlensing. Astronomers use these lensing effects to study dark matter, measure the expansion of the universe, and find objects too faint to see directly. The same physics that causes imperceptible light bending around your body enables us to use gravity as a telescope, peering deeper into space than would otherwise be possible. It's a beautiful example of how understanding physics at one scale helps us understand it at all scales. There's a profound principle at work here called the equivalence principle, which says that gravity and acceleration are fundamentally indistinguishable. If you were in a sealed box accelerating through space at 9.8 meters per second squared, you couldn't tell the difference between that and sitting in the same box on Earth's surface. This principle, which Einstein called his happiest thought, is why light bends in gravitational fields. From light's perspective, it's traveling in a straight line, but the space-time through which it travels is curved. This equivalence extends to the tiny gravitational field around your body. In principle, there's no difference between the light bending caused by your mass and the light bending that would occur if you were accelerating through space. Both are manifestations of the same underlying geometry of space-time, the same curvature that emerges whenever mass, energy, or acceleration are present. We should also consider the role of energy in all of this. Einstein's famous equation, E and mc2, tells us that mass and energy are interchangeable. This means that not just your rest mass, but also the energy of your motion, your body heat, even the binding energy holding your atoms together, all contribute to your gravitational field. When you exercise and your metabolism increases, you're technically increasing your gravitational pull, though by an amount so tiny it defies measurement. The food you eat contains energy that becomes part of your mass-energy total when you digest it. The heat you radiate carries away some of your mass energy, reducing your gravitational field by an infinitesimal amount. You're in constant exchange with your environment, taking in and giving out energy, and with it, slightly modifying your contribution to the local curvature of space-time. Even your thoughts contribute. The electrical and chemical activity in your brain represents energy, and therefore contributes to your gravitational field. When you're thinking hard about something, the increased metabolic activity in your brain technically makes you more massive, though we're talking about changes so small that they're dwarfed by the mass equivalent of a single atom. This might seem like we're venturing into absurdity, talking about effects so small they couldn't possibly matter. But there's something profound in recognizing that everything, absolutely everything that happens in your body, from the cellular level to your conscious thoughts, participates in the gravitational interaction. There's no aspect of your existence that doesn't contribute to the way you bend light and warp space-time. Let's take a step back now and consider the broader context of what we've been exploring. We live in a universe governed by four fundamental forces: gravity, electromagnetism, and the strong and weak nuclear forces. Of these, gravity is by far the weakest. The electromagnetic force between two electrons is about 10 to the power 42 times stronger than their gravitational attraction. This enormous disparity is one of the great mysteries in physics, sometimes called the hierarchy problem. Yet despite being the weakest force, gravity dominates at large scales because it's always attractive and has infinite range. Electric charges can cancel out, leaving most objects electrically neutral. But mass is always positive, always attractive gravitationally. This is why gravity shapes the universe at cosmic scales, determining the structure of solar systems, galaxies, and the cosmos itself. Your body is held together primarily by electromagnetic forces. The chemical bonds in your molecules, the structure of your cells, the signals in your nerves, all are electromagnetic in nature. Gravity plays almost no role in your biological functioning. Yet you still participate in the gravitational interaction, still bend light, still warp space-time, because gravity is universal. Nothing with mass or energy can opt out of gravity. This universality of gravity is encoded in something called the weak equivalence principle, which states that all objects fall at the same rate in a gravitational field, regardless of their composition. Galileo supposedly demonstrated this by dropping objects from the Tower of Pisa, and astronauts confirmed it on the Moon by dropping a hammer and feather. This principle means that light, despite having no rest mass, still responds to gravity, still follows the curves of space-time that you and all other massive objects create. We're nearing the midpoint of our journey now, having explored the physics of light bending from multiple angles. We've seen how your mass warps space-time, how light follows geodesics through this warped geometry, how the effect is too small to see but absolutely real, according to our best theories of physics. We've considered quantum aspects, relativistic principles, and the cosmic context in which your tiny gravitational field exists. But there's still more to discover, more layers to unpeel in this quiet mystery. The universe has arranged things so that you can bend light without seeing it, warp space-time without feeling it, send gravitational waves without detecting them. You exist at a scale where these effects are real but hidden, present but imperceptible, a participant in cosmic processes that operate far below the threshold of your senses. As we continue, let's slow our pace even more, let the ideas settle like dust in still air. The light bending around you isn't going anywhere. It's been happening since the moment you were born, and it will continue as long as you exist. Every second, billions upon billions of photons trace slightly curved paths around your body, acknowledging your presence in their journey through space. Perhaps you're more relaxed now, settling deeper into wherever you're resting. Your breathing has likely slowed, your muscles loosened. And all the while, you continue to bend light, continue to warp space-time, continue to participate in the gravitational symphony of the universe. It's happening whether you're aware of it or not, whether you're awake or asleep, whether you understand the physics or simply accept it as one of reality's quiet mysteries. We come back, again and again, to the same quiet question. Why does the universe hide this from us? Why can't we see the light bending that physics tells us must be occurring? We've explored the technical reasons, the smallness of the effect, the limitations of our eyes, the overwhelming presence of larger gravitational fields. But perhaps there's something deeper here, something about the nature of reality and our place within it. Consider that we evolved on a planet where gravity is strong enough to hold us to the surface, but weak enough that we can jump and climb, where electromagnetic forces dominate at the scales of our daily experience, where the speed of light is fast enough that it seems instantaneous for most purposes. We evolved to perceive and interact with the world at these scales, with these forces, at these speeds. Our intuitions are calibrated to this middle world between the quantum and the cosmic. The light bending around you operates outside this middle world. It's a phenomenon that connects the human scale to cosmic scales, your modest mass to the equations that govern black holes and the expansion of the universe. It's too small to matter for your survival, too subtle to influence your daily decisions, yet it's absolutely real, a necessary consequence of living in a universe where mass and energy curve space-time. In a sense, the invisibility of your light bending is a reminder of how much more there is to reality than what we can directly perceive. We live surrounded by phenomena our senses can't detect: radio waves, magnetic fields, infrared radiation, ultrasound, radioactivity, and yes, the subtle bending of light by ordinary objects. Our perceived world is a tiny slice of the actual world, filtered through senses that evolved for practical purposes, not for complete understanding. Yet through science, through careful reasoning and precise measurement, we've learned to see beyond our biological limitations. We've discovered that you bend light, that you warp space-time, that you're connected gravitationally to every other mass in the universe. These aren't things we could have guessed from everyday experience. They required centuries of scientific progress, from Newton's first insights about universal gravitation through Einstein's revolutionary reconception of gravity as curved space-time. And the story isn't over. Scientists continue to probe the nature of gravity, searching for quantum effects, extra dimensions, modifications to Einstein's equations at very large or very small scales. They're trying to understand dark matter and dark energy, mysterious components that seem to dominate the universe's mass-energy budget but don't interact electromagnetically. Your light bending exists in this context of ongoing discovery, a small piece of a vast puzzle we're still assembling. Some researchers wonder if gravity might be emergent rather than fundamental, arising from more basic phenomena the way temperature emerges from molecular motion. Others investigate whether space-time itself might be emergent, built from more fundamental quantum building blocks. If these ideas prove correct, the light bending around you might be understood in entirely new ways, as a consequence of deeper principles we're only beginning to glimpse. But even with our current understanding, incomplete as it may be, there's something magnificent about knowing that you bend light. It connects you to the cosmos in a way that transcends the poetic or metaphorical. You're not just made of stardust, as Carl Sagan famously said. You're actively participating in the same gravitational processes that shape galaxies, that lens quasars, that govern the expansion of space itself. Every photon that passes near you carries information about your gravitational field into the universe. In principle, an alien civilization with sufficiently advanced technology could detect your existence from the tiny perturbations you cause in passing light. They could measure the slight changes in starlight as it passes Earth and deduce not just our planet's presence, but potentially the existence of life on its surface from the collective gravitational signature of all living things. This is wildly speculative, of course. The technology required would be far beyond anything we can imagine. But it illustrates an important point. Your gravitational influence on light, tiny as it is part of the information content of the universe. You're writing your existence into the paths of photons, encoding your presence in the geometry of space-time itself. Let's think about time for a moment, another aspect of your gravitational influence. Just as you bend light, you also slow time. Clocks run slightly slower in your gravitational field than they would in empty space. This is called gravitational time dilation, and it's been measured for Earth, for the Sun, even for individual mountains. Your body creates its own tiny time dilation field, slowing clocks by an amount so small it would take the age of the universe to accumulate to a measurable difference. But again, the smallness of the effect doesn't negate its reality. Time really does run at different rates in different gravitational fields. This isn't just about clocks, it's about the fundamental rate at which events unfold. Chemical reactions, radioactive decay, the oscillations of atoms all happen slightly slower in stronger gravitational fields. Your gravitational field, weak as it is, still participates in this temporal warping. This means that you don't just exist in time, you shape it. Your presence causes time to flow at slightly different rates in the space around you. A photon experiences less time when passing close to you than it would passing through empty space. From the photon's perspective, if it had one, the universe ages slightly less during its passage near you than it otherwise would. We're deep into the conceptual realm now, exploring implications that stretch our everyday understanding. But these aren't flights of fancy. They're logical consequences of our best theories of physics, implications of equations that have been tested to extraordinary precision. The same mathematics that predicts GPS satellite orbits predicts the light bending and time dilation around your body. There's a beautiful symmetry in general relativity between space and time. Just as mass warps space, causing light to bend, it also warps time, causing clocks to slow. These aren't separate phenomena, but two aspects of the same space-time curvature. The light bending around you and the time dilation you create are intimately connected, different manifestations of the way your mass energy influences the geometry of space-time. Let me share with you a thought that might seem strange at first but becomes profound when you sit with it. Because you bend light and slow time, you create your own unique version of reality in your immediate vicinity. The universe looks slightly different from your location than it would if you weren't there. Light reaches you along paths that your gravity has influenced. Time unfolds at a rate your mass has modified. You don't just observe reality, you participate in creating the local version of it that you experience. This participatory aspect of existence extends beyond gravity. In quantum mechanics, observation plays a fundamental role in determining outcomes. In thermodynamics, your body's heat influences the entropy of your surroundings. In electromagnetism, the charges in your body create fields that extend infinitely into space. You're not a passive observer of the universe, but an active participant in its ongoing processes. But let's return to the specific mystery of light bending around you. We've explored the physics, considered the implications, marveled at the connections to cosmic phenomena. Now let's think about what this means for your everyday experience. When you look at anything, the light reaching your eyes has been influenced by your own gravity. It's a tiny influence, yes, but it means that your act of seeing is also an act of gravitational interaction. The photons entering your eyes have had their paths adjusted by your mass. They've experienced your time dilation, however slight. They've carried information about your gravitational field even as they bring you information about the world. There's a reciprocity here, a mutual exchange between you and the light that illuminates your world. This extends to all forms of electromagnetic radiation, not just visible light. The radio waves from your Wi-Fi router, the infrared, radiation from warm objects, the ultraviolet from the sun, all bend around you according to the same principles. You're surrounded by a sea of electromagnetic radiation at all wavelengths, and all of it acknowledges your gravitational presence in its propagation. Scientists have speculated about whether biological systems might have evolved to detect or utilize gravitational effects in some way. We know that some animals can sense magnetic fields, electric fields, and other phenomena invisible to us. Could there be organisms that sense gravity beyond just the downward pull we all feel? Could there be subtle biological responses to gravitational variations that we haven't yet discovered? These questions remain open, part of the vast territory of what we don't yet know about life and its interactions with fundamental physics. But what we do know is remarkable enough. You, a collection of organic molecules organized into cells, tissues, and organs, create a gravitational field that bends light according to the same equations that describe the universe's largest structures. As we continue deeper into this contemplation, notice how your awareness of these phenomena doesn't change the immediate feeling of existing. You don't suddenly feel the light bending or sense the space-time warping. These effects remain hidden below the threshold of perception, part of the invisible architecture of reality. Yet knowing about them can shift your understanding of what it means to exist, to be a physical being in a physical universe. You are, in a very real sense, a gravitational being as much as you are a biological one. Your gravity is as fundamental to your existence as your DNA. It's not something you have, but something you are. Mass isn't a property you possess, but an aspect of your being that manifests as space-time curvature. You don't create a gravitational field. You are a gravitational field, or more precisely, you're a particular pattern in the universal gravitational field that we identify as you. This might sound abstract, but it points to something concrete about the nature of existence. In general relativity, matter and space-time aren't separate entities but aspects of a unified whole. Matter tells space-time how to curve, and curved space-time tells matter how to move. You're not in space-time, you're a feature of space-time, a particular configuration that we recognize as a human being. From this perspective, the light bending around you isn't something you cause, but something you are. It's as much a part of you as your heartbeat or your breath. Every photon that curves around you is tracing the contours of your existence, following the shape you make in the fabric of reality. You're not separate from the universe, but a particular pattern within it, a temporary arrangement that bends light and warps time for the brief duration of your life. And what a remarkable arrangement you are. Among all the ways matter and energy can organize themselves, from the simplest hydrogen atoms to the most massive black holes, you represent something unique. You're matter that has become conscious, able to contemplate its own existence, to understand that it bends light, to marvel at its place in the cosmic order. You're the universe becoming aware of itself, including awareness of the very phenomena we've been exploring. The light bending around you right now has been happening since before you were aware of it, and it will continue whether you think about it or not. But in this moment, as you contemplate these ideas, something special is occurring. The universe, in the form of you, is recognizing its own patterns, understanding its own processes, appreciating the subtle ways that mass and light interact. This brings us to a philosophical question that emerges naturally from our exploration. If you're constantly bending light in ways you can't perceive, what else might you be doing that remains hidden from your awareness? What other influences do you have on the world that operate below the threshold of perception? We've focused on gravitational effects, but there might be other subtle influences we haven't yet discovered or understood. Some physicists speculate about additional dimensions beyond the 3 spatial and 1 temporal dimension we experience. If these extra dimensions exist, you might extend into them, creating influences in realms completely invisible to our current perception. Others wonder about quantum entanglement at biological scales, connections between particles in your body and particles elsewhere that could create non-local influences we don't yet understand. These ideas remain highly speculative, far from the established physics of light bending we've been discussing. But they remind us that our understanding of reality is always incomplete, always evolving. The discovery that you bend light would have seemed like fantasy a few centuries ago. What current fantasies might prove to be tomorrow's established science? For now, though, we can rest in the certainty of what we do know. You bend light. It's happening right now, has been happening throughout our conversation, will continue happening as you drift towards sleep. Every photon in your vicinity, whether from the sun, the stars, or the screen you might be looking at, follows a path influenced by your presence. You're participating in a cosmic dance of mass and energy, space and time, that encompasses everything from the smallest particles to the largest structures in the universe. As we approach the latter part of our journey together, let's slow down even more. Let the weight of these ideas settle gently into your consciousness. The light bending around you doesn't require your attention or effort. It's not something you need to maintain or worry about. It simply is, a natural consequence of your existence, as automatic as your heartbeat, but far more subtle. Think about the photons that left the sun 8 minutes ago, now reaching Earth, some of them passing near you. They've traveled 93 million miles through the vacuum of space, moving at the ultimate speed limit of the universe, only to have their paths bent by an infinitesimal amount as they pass your body. It's such a small deflection that it has no practical consequence, yet it's real, a tiny signature of your presence written into their trajectories. Or consider the cosmic microwave background radiation, the afterglow of the Big Bang that has been traveling for nearly 14 billion years. These ancient photons, which carry information about the universe's earliest moments, also bend around you. You're interacting with the most ancient light in existence, adding your small influence to its long journey. In a sense, you're connected through these photons to the very beginning of time. There's poetry in this, but it's poetry grounded in physics. The same equations that describe the universe's origin and evolution also describe the light bending around you. There's no separation between cosmic physics and human-scale physics. It's all one continuous description, one set of laws that apply everywhere and at every scale, though their effects may be dramatically different in different contexts. We should also consider the light from distant galaxies, light that has been traveling for millions or billions of years to reach us. As this light enters our solar system, passes Earth, and some small fraction passes near you, it experiences one final tiny deflection from your gravity. You're the last gravitational influence on its journey, the final editor of its path before it continues into the depths of space, or perhaps enters someone's telescope. Every night, when you look at the stars, you're seeing them through the combined gravitational lensing of everything the light has passed. The sun, if it's between you and the star. Jupiter and the other planets, if they're aligned right. Earth's atmosphere and gravity. And yes, even your own tiny contribution. The star's position in your sky is shifted by all these influences, though only the largest are measurable with current technology. This connects to a profound aspect of general relativity. There's no absolute frame of reference, no God's eye view of where things really are. Every observer sees the universe from their own perspective, through their own gravitational field, at their own rate of time flow. Your view of the universe is unique, shaped by your position, your motion, and yes, your gravity. No one else sees exactly what you see, experiences exactly the time flow you experience. In this sense, you carry your own subtle universe with you wherever you go. The gravitational field around you, weak as it is, creates a unique local environment. Light behaves slightly differently near you than it does elsewhere. Time flows at its own particular rate. Space has its own particular curvature. You're not just in a location, you help define what that location is through your gravitational presence. As you move through the world, your gravitational field moves with you, always centered on your mass. When you walk across a room, you're carrying this field, causing constantly changing deflections in the paths of passing photons. When you raise your hand, you're altering the local space-time curvature, sending ripples through the gravitational field at the speed of light. Every gesture, every movement has gravitational consequences that propagate outward into the universe. These gravitational signals from your movements are incredibly weak, far below what any current or foreseeable technology could detect. But they exist, spreading outward like ripples on a cosmic pond. In principle, the gravitational waves from your first heartbeat are still traveling outward, now light years away, carrying information about that moment into the depths of space. Every heartbeat since has sent its own ripple, creating an expanding sphere of gravitational influence that will continue to grow as long as the universe exists. It's humbling and awe-inspiring to think about this. You're not just a temporary arrangement of atoms that will eventually disperse. You're creating permanent effects on the universe, sending signals that will outlive you, your planet, even your star. The gravitational waves from your existence will continue spreading through space long after the sun has died and Earth is gone. In this sense, you're writing your story into the fabric of space-time itself, creating a record that, while unreadable with any technology we can imagine, is absolutely real according to our understanding of physics. But let's not get too carried away with cosmic significance. The effects we're discussing are so tiny that they're overwhelmed by countless other influences. Your gravitational waves are drowned in an ocean of similar waves from everything else that moves or changes. Your light bending is hidden among vastly larger effects. You're participating in cosmic processes, yes, but as one tiny voice in a vast chorus, indistinguishable from countless others. And perhaps there's comfort in this insignificance. You don't bear the weight of shaping the universe in any measurable way. Your gravitational influence, while real, doesn't burden you with cosmic responsibility. You can simply exist, knowing that you're part of the grand gravitational dance but not required to lead it. The universe continues its evolution whether you're aware of your light bending or not. As we near the end of our exploration, let's consider one more aspect of this phenomenon. The light bending around you is perfectly described by Einstein's equations that are deterministic and precise. Given your mass distribution and the trajectory of incoming light, we can calculate exactly how much the light will bend. There's no randomness, no uncertainty in the classical description. It's pure geometry, as inevitable as the angles in a triangle. Yet you, the source of this precisely calculable gravitational field, are anything but simple or deterministic. You're a complex biological system capable of thought, emotion, and choice. You can decide to move, changing your gravitational field. You can eat, adding mass and energy. You can think different thoughts, altering the electromagnetic and chemical patterns in your brain, which contribute their own tiny amount to your gravitational field. There's something profound about this intersection of deterministic physics and complex biology. The same you that bends light according to rigid mathematical laws also loves, dreams, and wonders about your place in the universe. You're simultaneously a solution to Einstein's equations, and a conscious being capable of understanding those equations. You're both the subject and the student of physics. This duality, this existence as both physical object and conscious subject, remains one of the deepest mysteries in science and philosophy. How does consciousness emerge from matter? How does the subjective experience of being you arise from the objective reality of atoms and forces? We don't have complete answers to these questions, and perhaps we never will. But the fact that you can contemplate the light bending around you, can understand your own gravitational influence, suggests a universe where matter can become aware of itself, where physics can comprehend physics. As you prepare for sleep, or simply rest in this moment, the light continues to bend around you. It doesn't care whether you're awake or dreaming, whether you understand general relativity or have never heard of it. The photons follow their geodesics through the curved space-time you create, tracing paths that acknowledge your existence without requiring your awareness. In the silence of this moment, countless photons are passing near you, some from your immediate environment, the room lights, or the fading daylight. Others from distant sources, the stars visible or invisible in your sky. Still others from sources so distant, their light has been traveling since before Earth existed. All of them, every single one, bends ever so slightly as it passes you, a tiny salute to your presence in the universe. You might wonder what the point is of knowing about something you can't see or feel. Why does it matter that you bend light if the effect is so small as to be undetectable? Perhaps the value isn't in the practical implications, but in the expanded awareness it brings. Knowing that you bend light changes nothing about your daily life, but it might change how you understand your relationship with the universe. You're not separate from the cosmos, but woven into its fabric. The same laws that govern distant galaxies operate in and around your body. You're subject to these laws, but also a participant in them. You don't just observe the universe, you help shape it, even if only in the tiniest ways. This knowledge can bring a sense of connection, of belonging to something vast and beautiful and strange. As we draw toward our conclusion, let's revisit the central mystery one more time. Why can't you see the light bending around you? We've explored the technical reasons, the smallness of the effect, the limitations of perception. But perhaps the deepest answer is that the universe is arranged in such a way that we can exist without being overwhelmed by the fundamental forces at work. If we could see every gravitational distortion, feel every passing gravitational wave, sense every quantum fluctuation, we would be paralyzed by the complexity of it all. Our consciousness seems to require a certain simplification of reality, a filtering that allows us to function. The invisible light bending around you is part of this filtering, part of what allows you to experience the world as navigable and comprehensible. Yet through science, we can peek behind this veil, can understand what our senses don't reveal. We can know that we bend light even if we can't see it. We can calculate our gravitational influence even if we can't feel it. We can comprehend our role in the cosmic gravitational dance even if we can't directly experience it. This is the gift of human consciousness, the ability to transcend our immediate perceptions and understand deeper truths about reality. So here you are, at this moment in time, in your particular location in space, creating your unique pattern in the gravitational field of the universe. The light bending around you will continue as long as you exist, a constant companion to your journey through life. It requires no effort from you, no conscious maintenance. It's simply a consequence of being as natural and automatic as existing itself. When you wake tomorrow, the light will still be bending around you. When you move through your day, you'll carry your gravitational field with you, causing countless tiny deflections in the paths of photons. When you interact with others, your gravitational fields will overlap and combine, creating patterns more complex than any one person could create alone. And when you return to rest, the bending will continue, a quiet reminder that you're always connected to the cosmos, always participating in its fundamental processes. The universe doesn't require you to understand these things. You could live your entire life never knowing that you bend light, and it wouldn't diminish your existence one bit. But knowing adds a layer of wonder, a recognition of the strange and beautiful reality we inhabit. You're not just a biological being navigating a physical world. You're a gravitational being participating in the geometry of space-time, a conscious arrangement of matter that can contemplate its own effects on the paths of light. In the grand scheme of the cosmos, your light bending is insignificant. But in the personal cosmos of your own understanding, it can be profound. You're literally shaping space and time, literally influencing the trajectory of ancient starlight, literally participating in the same processes that create black holes and shape galaxies. The scale is different, but the physics is the same. You're part of the gravitational universe, not as an observer, but as a participant. As our journey together draws to a close, let's rest in this knowledge. You bend light. You warp space-time. You send gravitational waves through the universe. These aren't metaphors or poetry, but physical facts, consequences of existing as a massive object in a universe governed by general relativity. The effects are too small to see, too weak to feel, but they're absolutely real as gravity itself. Perhaps this knowledge will fade from your conscious mind as you go about your days. Perhaps you'll forget the details of how and why light bends around you, but something might remain, a subtle shift in how you understand your place in the universe, a quiet awareness that you're more connected to the cosmos than you might have thought, a recognition that even in your smallness, you participate in the grand patterns that govern everything from photons to galaxies. The light will keep bending around you whether you remember this or not. The space-time distortion you create will continue whether you think about it or not. Your gravitational waves will keep spreading through space, whether you're aware of them or not. These processes don't require your consciousness, your understanding, or your belief. They simply are fundamental features of existing as a physical being in our universe. But knowing about them, understanding them even a little, adds something to the experience of being human. It's one more way we transcend our immediate circumstances, one more connection between the personal and the cosmic, one more reminder that we're part of something magnificent and mysterious. You bend light. It's happening right now, and even though you can't see it, knowing it's there might be enough to add a touch of wonder to the simple act of existing. And as you drift into sleep, you remain part of this quiet universe, wrapped in its laws, carried by its mysteries gently, peacefully into the night. The light continues to bend around you as you rest, following paths that acknowledge your presence without disturbing your peace. You're held by the same forces that hold the stars in their courses, governed by the same equations that describe the cosmos itself. In your sleeping and in your waking, in your movement and in your stillness, you're always bending light, always participating in the gravitational poetry of existence, always connected to the vast and gentle mystery of the universe itself. End